One of the first things I like to do is figure out what size of ring I want to make. So this is where we use our chart. I'm going to say we're going to make a size 7 ring, and that's in US sizes. And then the salient thing that you need to know is the thickness of your metal. So we're going to take this piece of ring material, the shank material. I'm going to take a caliper and I'm going to zero that out, do it in millimeters, and measure it. It's 1.9, yeah, it's about 1.9. Okay, so with this chart, you can go to a size 7, and up here at the top of the chart, what gauge is our metal? What does this 1.9 millimeters equate to? Well, here we have 14 gauge is 1.6 millimeters thick, 12 gauge is 2.1, so we're kind of between a 12 and a 14 gauge here. We're going to split the difference between these two columns. It looks like we need between 60 and 59 millimeters. Now, if you had a thinner or a thicker shank material, you'd use those measurements. Here we have up here, we've got a 22 gauge is 0.6 of a millimeter, so that's thinner. So what would that do? That would mean we would need actually less material. So let's see if that's true. Here's our size 7. Go over on a size 7. Yeah, in a 22 gauge, you only need 55 millimeters of material. That's because if it's thicker, when it encircles your finger, it's taking up length as it bends the thickness. It takes up length because it's so thick. There's thickness that is basically absorbed in the bending. How about that? So this is a great little chart. Highly recommend it. So we decided we needed 60 millimeters. There we have about 60. Oh, guess what? We're not making a straight band, are we? We are making a design. So here's where you have to make a few considerations. We're doing a design with a split and then a flare. That's going to take some length. So if you add a little curve here and a little overlap, you're adding length. So for good measure, let's add 10 millimeters to this ring shank length. That'll give us some extra to do our extra bending. We'll cut off what we don't need in the long run to do our, oops, boy, I had the wrong size of blade in here. This is a 0.8. It's about the width of a hair, so we don't want that. That'll just break. So let's get something a little sturdier out here. How about a 2/0? What's this? I don't know. It's thicker though, and it'll work. Let's do it. Let's just put this in your bench pin, V. Get your fingers out of the way. You never want your fingers where you're going to slip and cut them. You use your bench pin to protect your fingers. Get them out of the way. So let's just cut it. Oh, you might want to use a little bit of a wax lubricant if you have it. Makes the cutting go better. Just cutting, cutting. Slow down toward the end. Boom. We want to split this silver, the lengthwise on both sides, and probably, I would say, yeah, we're going for at least a 10 or 15 millimeter split. Why don't we do a 15? And I'm going to use one of the handiest tools ever devised, which is a little divider. You don't have to worry about math. You just use your divider to make marks. So I'm going to kind of guess where halfway is. I think that's not quite. I'm going to look at it. Looks like I've got about halfway. So if I do a little mark and then I come on the other side and do a little mark, they need to match up. That way I know I'm there. That's pretty close. So I'm going to do from both sides. And I know if I go right down that line, I have the center of my material. A little bit of lubrication. Now this is very important to keep your fingers way back from the end of your V to protect them. I'm going to use my optivisors here. I'm going to do a little bit of I'm going to give that a little start. I turn it sideways to get the blade started, and then I come right at it straight. And I'm just going to saw right along. I'm using my fingers to just clamp that right down. Keep your saw blade going up and down perpendicular to your work to the degree you can. Let the saw blade do the work, don't push it. Just keep it moving. If your saw blade is too small of a gauge, it's going to want to zigzag and wander. So use a bigger blade if you have that trouble. Generally, the thicker the metal, the bigger the gauge of saw blade. One of the things you need to do pretty quick in a design is to make your gemstone setting, because everything is in relation to it in a ring that features a gem. So you want to have that made, and then you can place it and be much more accurate. Now, to figure out the length of bezel material, you could measure it. I tend to just wrap the stone. Just looking at the height I like. You want it to come slightly over the curve. You have to have the wall come up and be higher than where the stone starts to curve to the center, so that you have a place you can bend your silver onto to hold the stone. So I think this kind of height would be good. So I'm going to just mark it along here. So I could cut that much off. What a pain. Okay, well, you could cut it with a snip. This is going to distort it some probably, but I'm going to do it because I don't want to take the time. Okay, I'm going to cut it off here. Okay. So here's a piece of bezel material that looks like a much better height. See that? Much better relationship. Okay. To make a bezel, I'm just going to file that flat. It's got a little bit of a roundiness to it. It's just, I don't exactly wrap. I use some pliers. These are flat on one side and rounded on the other. It's called a half round plier. And I'm going to get the contour I want for starters. These pliers have a taper, so be careful not to get that taper in your bezel so that it, flares in or flares out. And I'm getting kind of close. When you look at things, look at it through to the white card at the back, and you can see what's real. Like, I can see a big gap there, and I can see where the bezel's not fitting perfectly. So I know what to allow for. I'm going to make a mark right about here that corresponds with where the overlap begins. And then that's where I can cut it. But that, I use this viewing method for looking at prongs, for looking at open jump rings, anything that's hard to see, this will help you see better. When you solder, you really want these ends to match beautifully. And that will give you your best seam. Since we will have several soldering operations on our ring, the conventional wisdom says to start with hard solder. With your initial solders, that flows at around 1370 to 1490 Fahrenheit, so that when you do subsequent solders, don't risk melting your initial solders if you're careful. We're going to do a conventional solder on a soldering block of charcoal. So the classic way to get started is to take a boric acid and alcohol saturated formula, dip your piece in it, and then I'm going to put a little flux on this seam and down onto this piece of solder here that is right there. Okay, let's see if that works. It's still, you want a flame that is not too hot. Get just a hair of a yellow tip there, but not much. Now it's fluxed, my seam is fluxed, my solder is fluxed. So this is thin material. Keep your flame moving. And I'm heating lower onto the soldering block where the solder is, not just on my bezel material. In fact, I'm heating mostly the soldering block. If you can see that. And you don't want to overheat any one spot, but you want to bring the whole thing up to temperature, concentrating your heat on your little piece of solder. Keep that flame, actually I'm pointing it down quite a bit, not across my material. There, did you see that? There, it flowed right up where I wanted it to go. Perfect. I'm bending this with I'm prying it open with a little screwdriver. It's pretty stiff material, but let's give it a bend here. Just kind of wedging it in there and levering it up, but it's pretty stiff, okay, because it's thick. So if we want to be able to bend this around and do much with it, I think we're going to want to anneal it. But let's give it a few bends first so we don't waste our annealing. Get the most we can out of every step. So I have some very cool pliers here. These are a forming plier. It's got a V and like a curved thing, and that will help form it. Use some leather to protect my material so we don't get tool marks in it. Okay, and now what we'll do is do some bending here before we anneal it, and then when we won't have to anneal it as much. And then we'll anneal this and it's going to bend much better, but let's get it started before we anneal it. A lot of times milled material, so this has been milled into a bar on a metal, some sort of metal mill, possibly extruded, and that hardens it. So this is not a perfectly soft material right now, although silver is very soft. So now we have a nice curved start, but that is nowhere near a ring shank. So why don't we anneal this? Put it in your boric acid and alcohol. And the reason you do this is to help prevent fire scale. Fire scale is the result of the heat. It brings the copper. There's copper in sterling silver, so the fire scale is the result of the copper coming to the surface, and it creates dark, shadowy areas on your piece. That's not what you want. And annealing is about a few things. It's about temperature and getting it to the temperature that will allow the molecules that are in the metal that have gotten themselves compressed by being bent or milled or hammered upon, you get those molecules to relax and realign themselves in their original sort of state that they want to be in. Now I'm going to use a little bit bigger torch just because I have it, because in annealing a larger piece like this you want to use a rather bushy flame, a little bit, not too hot. Use good overall heating and bring it up to just a kind of red hot. Hold it there for several seconds, 20, 30 seconds, and then you want to quench it. And if you quench it, you will basically freeze the molecules in whatever relationship they're in at the time they are quenched. So I'm moving my flame along, back and forth. I'm heating the charcoal block as well, letting the heat sort of bounce off of it onto the ring shank, and that helps with even heating. If I just went like this, across it like this, it would work, but I would risk getting the top half, these little arms up there, a little hotter. So let's go for even heating. I'm pointing it down onto my solder block and letting that heat reflect back up in a more even manner. And I'm seeing that the color is getting a little bit red. I don't know if you can see that. Now those ends are going to get hotter quicker because they're thinner. So concentrate your heat toward the center. You can see how red that's getting. Okay, I like that. Just hold it there. Don't let it get any hotter than that. You can tell by the color. Hold it there for 20 seconds or so. And looking good, looking good. I'm going to turn that off. And then I'm going to, while it's still slightly red, I'm going to quench that in my pickle. Oh, that was hot. Psh, that was hot. Okay, could have let it cool a few more seconds there. But still, now you would be amazed at how soft this material is and how easy it is to work with. Beautiful bezel. It's all nice and fit. Looks really good. Okay, so now we have this piece of ring shank material, and let's look back at our drawing, what we're trying to achieve here. So we've got our ring shank material, we've got to flare that a bit, and then we'll cut this piece to fit, this little piece. And we know we want one side to flare out to surround that. So let's see if we can do that. We know we want that to come out beyond. Okay. Oh, actually, before we do that, we should probably bend this around some more. But this is going to help us bend. Now, every time you bend it, work hardens a little more, so you may have to anneal this again, but now you know how. Go back through, do another pass. Do things slowly so that you stay in control. We're trying to make, yes, an asymmetrical design, but it still needs to be round at the back and not get wonky on us. So you can see how it's starting to offset, and that's because this is not, it's got a bit of a taper or a slant to it, so let's just pull it back. There. Pull it back a little bit. I'm going to do it without the leather to just do it more quickly and show you better. That way you'll see it. We'll clean up those tool marks later. Okay, now we have got something here. Okay, so we need to flare out our ends. You know what? We might have to cut a little further to get a little better split. I think we will. Let's do that. Let's just carefully cut a little further so we have a little more leeway on that. It's going to give us a better curve. You don't want the curve to look truncated or short. It needs to be enough curve, and so we give it a better starting split here. Bending it out a little. This can lever against, kind of lever. That opens it up a little more. I have spread our little split shank open a little bit, but now it needs to go further open because I want to get this oval in between two arms and have them wider than the oval. So clearly we have to open it some more. If I want to make this curve flare out, I'll put the flat part on the inside and the rounded jaw on the outside so that when I bend it, I won't get a crease mark from the corner. If I put it the other way or used a pair of flat pliers and I tried to bend it, I would get a nice divot from that sharp edge out there. So you put the rounded edge that you want to curve around. So I'm just going to attempt to bend it some, open. It's a little bit of a stress there, and do it on the other side. It's getting closer, but we could go a little bit wider. A little bit wider. Okay, now we're cooking with some gas. Let's see what this looks like. Yes, I like it. Okay, so next step is to figure out how to fit. Oh, that's going to fit in there very nicely. Another thing we need to do, so we need to finish these inside edges. We need to fit this piece so that it sits in our V nicely. And then we also need to put a backing plate on this cabochon because we need to have some structure back here. I don't believe that I want to completely seal the back up because I want to be able to see through the stone. I want to be able to clean the stone. So what we do need though is at least a rim so the stone has something to sit on and be set against. So what typically you would do, get a piece of something that has the thickness that you like. Okay, here's a nice piece. And we'll take the stone out, we'll get this to fit, and we'll solder it on a sheet, cut it out, and then cut the inside out and just leave a rim on the inside of the oval. Just work along on it, see where we get to. It's just all process, and it's fun. It's an exploration. You don't have to know exactly everything that's going to happen before you make something. One thing I really like is the exploration of developing a design and making judgments every bit of the way. You decide what you're doing. Do you like this? Do you like that? This height, that height, more curve, less curve. Ooh, let's add something else. You know, it's your choice. There's no rules here. You just decide. I'm going to just make that fit a little bit better. Before you solder it on something, if you've done any sort of manipulations, a good thing to do is to make sure the bottom of your bezel is flat. It's got little, uneven bits. So rub it on some emery paper, and you can, when you look at your sanded, also rotate it so you don't get uneven pressure. Oops. Then when you look at your sanded surface, look at the reflection of the light and see if you have any imperfections, high spots, low spots. You can see it. It'll reflect differently. See, I see one little spot. We need to go a little further. So just one little tweak there. Now, solder always flows better on a fresh surface, so even if it's nice and flat, give it a little emery to freshen up that surface, take off any oxides and oils that might interfere with your solder flow. And it also tells you how flat your surface is. Looks like it wasn't quite as flat as I thought. Let's go for another minute here. It's going to sit there. That's nice and flat. Look at it from the side, and I think that looks fantastic. Okay, so one thing I like to do when I solder things, a piece like this, you could set it right on your soldering block and heat from the top. The risk is that you'll melt your bezel before you get your temperature up to where it needs to flow the solder. So how would we set this up to come from underneath? And let's look at that. One way to do the soldering is to do it on a screen. And this is a soldering stand here. You can get these soldering stands. It's got 3 long legs. I can zoom out and show you this better, can't I? Zoom, zoom, zoom. Okay. Yeah, it's got 3 long legs. It's got a screen on top. This is overkill for what we're doing here in terms of the stand, but the screen is perfect. So let's take that little screen and let's just prop it up on something else. Got my flame where I like it. I like just a bare tinge of yellow at the front. This is not a huge piece. It doesn't need a lot of heat, it just needs even heat. So I'm moving the flame around. I'm going to zoom out just a little so you can see how I move the flame around. You control the heat by the motion of your flame. See, now the flux is bubbling up and then it's settling down, then it turns into a glassy substance and protects your metal. Okay, So now I'm going to zoom in a little and put some solder on there so you can see it melt. That's what we want. We want to see it melt. Okay. So I'm going to pick up going to blow out my torch. Okay. I'm going to pick up a piece of solder here. I'm going to carefully place it and gently shove it next to the seam. I'm going to pick up a little bit more. You should put some flux on this, on your solder pick. I'm going to pick another piece. Put that next piece right. Come on, come off my solder pick. There. Okay. Now I need to make sure that's touching the seam. If it melts away from the seam, it's not going to do us any good. I'm going to come back underneath. I'm going to move this torch around, keep it moving. That's your control, is the motion. If you just kept it in one place, you would way overburn your overheat, and you'd probably melt something that you don't want to melt. So keep your eye on it, keep things moving, and eventually everything should just go bloop. And keep your hair out of the way. I'm just moving this. I'm watching the color. It's coming up to red. And there, it all just went. Just flowed like beautiful. Just right there. Do you see that? Nice and glassy. If your seam is great and tight, you don't even need that much solder because it just flows by capillary action and fills in the gap. Solder forms a third metal. You have sterling silver. You have your silver solder, which has a higher copper content to lower the melting temperature. And then the silver and the silver solder form a third metal called a eutectic, and it bonds. It migrates into both pieces of your silver and forms this third. It's not like glue. It actually bonds into it chemically. So we're going to let it cool for a minute, and then I'm going to quench it in the pickle. Okay, while that's pickling, we're going to go back to our ring shank, and we're going to work on these surfaces right in here on the inside of that V, clean those up, and then fit our little piece of textured material in there. Now I'm going to show you something about my flexible shaft that is a bit different than the average flexible shaft. I've had issues with my hands over the years, and so I made a thermoplast handpiece to be able to grip the handpiece without putting as much stress onto my my thumb joint there. And so I found this to be a really nice addition. I've also done it on my file. I put a big mound of thermoplast here on my file, so now I can use my file without collapsing my joint, my thumb joint. So those are things that have helped me. I probably, if I'd done it a couple decades sooner, I might have been in a better situation. This actually just comes off. It just really does come right off of here. If you just pull it, there, see? It's just some thermoplast. You heat it, get it at a jewelry supply, heat it in some near boiling hot water, take it out, and then just form it how you want. And I've got it so it kind of snaps right on there. It's really helped me out. Okay, so I'm just going in and feathering and keep it flat, because this sanding disc can cause serious divots in a flash, and then you have a whole lot more to flatten out than if you'd never used it. So now if we look at this, we've got the same finish on both sides of the V. There's no divots to speak of, and now I can go ahead and take this piece, see if we can make a nice piece to fit in there, which is pretty close. I'm going to take those handy dandy pliers, put the curved part on the part that I want to curve, so I'm curving around the curve, and the flat part is on my texture so I don't put any dents or divots in it. I see over here just a hair in this area. Yeah, see how nicely that's fitting in there? What you don't want to do is cut into your bezel by accident. So give it, a fraction of a millimeter of berth. Don't cut the base of that. That is very frustrating. Then you have to go in and trim it up or fill it or do something. So don't hit your bezel. Stay a few tenths of a millimeter away from it, or more if you want. Sometimes I leave a little rim, a little step at the bottom. I do it maybe half a millimeter out or a millimeter out, and use that as a design element to create a little step down or a little rim, and sometimes I put texture on it. Keep your fingers back when you finish that saw cut so you don't get something cut up there. Okay, now we have a nice bezel. At this point, you don't want to trim it back to wherever you want it to be. I would use a file or a sanding disc or whatever you like. Looks like actually this side, kind of the V is a bit shorter. It's not as deep. So what we need to do is cut some of this off to make room for the cabochon in there. And remember I said I didn't know exactly how much it would take to accommodate the flaring and stuff. So better to have too much than too little. But it looks like we've got to cut some off to make room. This is going to sit here in between those two there. Then how much do we cut off over here? Not a ton. Except it's going to be really big. It's way too big. Let's see. And I'm going to use some snippers and see if this works. We're going to cut off about there. Yep. And we're going to cut off about over here. I'm eyeballing it, bad Mary, but you should probably measure this. These are sort of heavy snippers. Let's see if that got us closer to where we want to be. What we need to do now is refine this, make a little curving end here and a little curving end here, and then that should fit right in pretty well. I'm going to use a cutting disc. So I don't want to bump this corner or this corner. So I want to come in and just work carefully around that, fitting in here. And what we have to do to finish this idea. So consideration is what do we want this to look like where this nice textured piece meets this? Do you want this to be square? Do you want this to be round? Do you want it to be with a radius? Do you want it to be more tapered so that it's thick and thin? And how do we want this piece to end up here? Do we just want it to be a chunky? You're going to look at your drawing and maybe your drawing tells you, maybe it doesn't. Maybe your drawing doesn't really have enough information. It's a pretty sketchy drawing, wasn't it? Well, that leaves a lot for me to think about, doesn't it? But we're on our way. Let's fit our little plate of texture in next. I think what I want to do is round these up a bit here. And I might taper this in and give it a little more gracefulness. But we can do that part later. But we do need to get this inside edges a little bit rounded before we solder that plate in, so we don't risk damaging the plate by trying to detail it afterwards. So you can use this file, but I'm going to use my sanding disc, and I'm going to come in and start this by feathering it down a little with long, careful strokes. See how I'm bracing my hands together? It may look like I'm not supporting the work, but my hands are the support. One hand is on the bench pin, the other hand is braced against it that match your curve. And finish that kind of how you like. The decisions never stop. Every tool you pick up, every part of your sequence, you're making a choice. You're making choices about relationships and shapes and spacing and finishes and textures and on and on and on. It never ends. That's the fun of it, though. That's what you're creating as you go. This is a flat file on one side, and it's got a little edge here on the other side so that I can go in, and I'm not going to file anything with this back side. There's no teeth on it. You wouldn't want to go in with teeth on both sides, or you'd start messing up the other side you don't want to get any file marks on. So match the tool to what you're trying to accomplish. Look at that nice fit. The key here is going to be to get this propped up in the right way so that it stays where you want when you're soldering it. And I don't want to get any solder in the front of the sheet and obscure our nice texture. So let's see, I've got this, I use the third hand. This is kind of a fancier one, but you can get a regular old third hand, and they're not expensive. And I'm going to put this in, see if I can get it to lay where I want it to be. I might not. It needs to be down in the, okay, that's more like where I want it, right there. I wonder if I got a little piece of solder. Oh, there. Oops. Okay, this is not going to want to stay. So what will we do? We have to figure this out. How are we going to make this piece stay where we want it to be? Change the angle. That might help. Oh, that worked a lot better, didn't it? Okay. So I changed the angle so gravity is working on my side. How about that? What's going to be key here is if it starts to move, is to be able to nudge it back in place while the solder is melted. This is a kind of a tricky thing we're going to do here. So let's see if we can keep our focus good. Stay there, focus. Okay. I'm going to heat it up a little. Okay. I'm going to heat it up. I'm going to keep this flame moving. I'm going to watch it while it gets warm so that I make sure it stays in place, and if it moves too much, I'll just push it a little bit, because you can move things around before the solder. Okay, I like where it is. I'm going to pick up some solder with my solder pick here. I'm going to place one here in the V. That's an important place. I'm going to place one. I'm coming at it from the back so that we hopefully can keep the solder from migrating to the front. I'm going to place a little ball of solder right there at the top. I'm going to get another one here. I'm going to place it over here at the top. Just wanting to migrate around a little. Okay, come on. Go where I put you. There. Now I have 3 pieces of solder. Can you see that? Okay, good. One at the top of the V on each side and one at the bottom. That's probably enough because we have a nice seam. Now I'm just going to heat this with keeping my flame moving and knowing that, for example, the sheet is thin, the shank is thicker, so we don't want to overheat the sheet and the top of the shank where it's thinner. We know it's thicker down here at the bottom of the shank. We're watching our color. Watch our color, keep it moving back and forth. What's thick heats up slower and cools slower. What's thin heats up quicker and cools quicker. So you keep your heat lower down on this piece rather than up at the top. But include the top. And let's see, we should be able to get this to move. We're getting close. Can you see the colors getting nice and red? Should be going. Yeah, there it goes. Okay. The ones at the top went. Now the one here down at the bottom needs a little more help. I'm going to get a little more heat in there. See if we can get that going. I don't like that one didn't flow all the way. I'm going to get a little bit more flame. I see I could have used a little bit bigger flame here. So not too much. And I'm going to take one last piece of solder that I have cut. I'm going to stick it down in the bottom of the V, because I think that's where it's going to have not flowed properly, because it's got a little more. Okay, get off my solder pick. Try that again. Get it right out at the edge of your solder pick. Get it right where you want it. There. Now, I'm going to come at it from underneath a little bit this time and pull that solder through the V. But I'm heating the bottom of the shank more than I'm heating up where the solder's already flowed. I'm including it, but I'm concentrating. How are we looking over there? Oh, good. We're concentrating our heat down at the bottom here, because I want that solder to pull through at the bottom of the V. I might just push this little piece up a little, right in there. Come on, you little. There. Okay. Now, watch your heat. We've got our red hot. We're ready to flow. Pull it up. Come on. You can do this. Give it a little nudge. There you go. Yeah. Okay. Trying to give this just a little more. There. Got really nice flow there. Very pleased with that. And on the back side, got really good flow there. Probably going to cut back maybe this much. What do you think? Let's see. Let's take a look. Take our tweezers. Take this piece. Yeah, we're going to have to cut it back at least that much to get this to sit where we want it to. And what you're watching is the back side down here, so you don't hit it with your saw blade. That would be what you don't want to do. I'm protecting my finger very well, so I'm being very careful. Not putting much pressure on the saw frame. Let the blade do the work. Watch the bottom where you don't want to cut your silver. And carefully forge ahead. And slow down. You can hear the sound change. You're getting close. Slow down, slow down. You don't want to, when you cut through, make a problem. So close, I think I can probably just come in here and take a piece of pliers and twist that right off. Well, it almost meets up. We'll just have to grind that out a bit. Let's give it a try. It's an inverted cone burr. Oh, this will chatter. Hold on pretty steady here. So I'm not trying to cut the top edge of my textured area at all. I'm trying to cut toward the finger end of it. Now, danger when you get over here because it'll want to chatter off. Looks really good. Okay, so now what do we do? Well, before we solder this in, this bezel, we've got to get this all nice and shiny. I've set this ring up to solder the bezel to the shank. I've used hard solder so far on my operations. Now I'm going to use some medium hard. You can use medium. The idea is to drop your solder temperature so that you don't risk melting seams that you've already soldered. So you sequentially move down through the solders. I tend to not use soft solder unless it's absolutely necessary. I stay between the hards and mediums. So you want a fairly large neutral flame. And I've got everything fluxed and set up. You could do this with the top of the bezel up. I just happened to get a good setup here on my first try. So I thought, oh, I'll just do it this way. That way I can see keep the solder at the bottom of the ring. I'll have less cleanup on the top surface. Every operation you do, you want to take into consideration what you're doing for the next step, which is usually having to clean up your tracks, or you know, so don't leave a lot of extra solder on these seams, and don't leave tool marks, all that kind of stuff. And you just set yourself up for more work every time you do something like that. So be efficient. So I've got solder in 4 places. You can't see 2 of them. I'm just going to do, oops, blew my torch out. Okay. I'm going to heat the piece all around. Silver wants to be hot all over before you go in and concentrate the heat in certain areas. There. I'm thinking this is going to look very nice. I think I might add some gold accents to some of these pieces too. That'll be a nice look. I do use my optivisor so I can see more closely what's happening. We're getting up to temperature, heating everything. I may come around, if I get the solder on one side flowing, I'll then move my torch to the other side. We're almost there. Take your time, not too much time. The solder can get a skin on it of oxides and then it won't flow, but this will flow. Starting to go right now. Oh, nice. Got all of it going. Very nice. Okay. The only question I have is I have a fairly long seam over here where the inset piece of textured metal is, and I don't know if I had enough solder to flow it all the way. So I'm going to take another piece of solder, since I have one cut, and you can't see it very well, but I'm going to put it in that seam. It looks like there's actually some space there, so I don't want that. So let's definitely make sure we get that seam. I'm going to put more underneath. And that is definitely an area you don't want solder flowing into from the top, because that's got your texture. If you end up with solder flowing up there, you have to get rid of it, and usually with abrasives. And of course, if you have a beautiful texture, you don't want to do any soldering or filing on that. That would not be good. So I'm going to go in and reheat, concentrating, after I get everything up to temperature, concentrating on that seam. And I can see it from where I am. You can't, but I can. And okay, I'm ready. Move your flame back and forth across the seam, because you want both sides of that seam to be equally hot, or the solder may migrate to one side where there's more heat. That is not what you want. Now I have to bring it back up to temperature. I lost some, but it will only take a minute. I want to draw some of the solder off to this other side of the ring. If I put my heat here, the solder will go there. And, yes, okay, there we go. I like it. See, where I use my leather and I can squeeze that, because that got super hot, and you just reach over, grab it, and burn yourself. So use your leather. It's a good little hot pad. I don't know how well you can see it, but the solder stayed nicely in the seams. There's some weird color. That's just from the different chemicals in the flux and reacting to the heat and stuff. But I didn't get any solder flooding into my pattern, which is great, because you cannot reestablish that. So that is a good reason to heat from behind on this one.